pencil in, I guess, right?
Well,
or that was the foxhole one.
That was the foxhole
Yeah.
one.
This Amateur Radio Roundtable is brought to you in part by Icom America. All right, and hello to all of our gang out there tonight that's tuned in. You're watching Amateur Radio Roundtable. I'm Tom Medlin, W5KUB. And today is Tuesday, September the 17th. I almost didn't know the day there. Hey, if you're listening to us out there on International Shortwave Station, WBCQ, you can watch the show if you'll go to W5KUB.com. That is, if you have internet. And if you are listening out there and you do get around to your email, send us an email to tom@W5KUB.com and send us a signal report where you are, if you heard the show, where you heard the show, and so forth. I want to invite everybody out there to join our ham radio Facebook group. It's just called W5KUB. Just do a search on Facebook for W5KUB. We've got over 8,000 hams in that group now, and it's growing pretty fast. So it's just a great place to talk ham radio, to follow the show, put your shack pictures in there. And talk about ham radio. There's plenty of people in there that can answer questions if you need help with something. So let's see. Oh, hey, just one announcement here. Hey, VRX sent me this. Voice of America, Bethany Relay Station is having their 75th anniversary special event coming up soon. It's going to be on September 21st. It's going to be under the call WC8VOA for Voice of America, and that's the Westchester Amateur Radio Association is putting that on. They're going to be mostly on 40 and 20 meters, mostly sideband, some FT8, and maybe some CW. And we'll have a certificate they can send out to you. So that's the Voice of America Bethany Relay Station 75th anniversary. Check it out on the internet, get more information about that. So
that's in Westchester, Ohio.
So we've got Bill back with us tonight. We've got a light crew tonight. It's Bill and Tom tonight. Let's see, Bill. How you doing, Bill?
I'm doing fine. Is that the Voice of America station, the one between Dayton and Cincinnati? That in Ohio?
You know, I don't know. It says Bethany Relay Station. I'm not sure.
Okay.
But it is an 8, so I would imagine it's up there somewhere, you know.
Because they have during the Dayton Hamvention, they often give tours of the VOA site, which is well worth the trip. It's about 20 miles or so south and southwest of the Xenia, so it's worth going to.
Yeah, I've looked at it every year we drive up. Now, didn't they close that down, or maybe they're still giving tours? But it's off the air.
They still give tours of the shack. At least they were a couple of years ago.
Yeah. Okay. All right. Well, look, I know you've got some trips planned, and you've got a lot of things you've got to do here tonight to get ready for those trips. But haven't had you on here in a while. Haven't talked in a while, and we're waiting for the perfect date to launch our balloon. So if it's if it's November, December, that's fine with me. We want the perfect one.
Yeah, it'll probably be sometime in October or November when the winds really kick up, and you can get about 200-mile ground speeds and get around the world in about 11 days to 2 weeks.
Yeah.
So.
Well, I was going to make a little joke. I was going to make a little joke real quick about the perfect date. There was a TV movie. There was a movie. Let's see if anybody in the chat room knows this movie. and they were interviewing this lady on there. It was kind of like a pageant. They were interviewing her, and they said, "Describe for us your perfect date." And she said, "September the 14th. It's not too hot, it's not too cold." So anyway, maybe somebody will know what movie that came from. It was a pretty funny movie there. Well, anyway, so we're waiting for the perfect date for a launch. No hurry, but you've got a tracker, a sky tracker on several balloons flying right now, and let's talk a little about what's going on. Maybe you want to mention first where you're going here soon, and then let's just jump into it.
I'm going to the Digital Communications Conference this weekend in Detroit, Michigan. It's right at the airport, Marriott, I believe. And if you go to tapr.org, that's tapr.org/dcc.html, I believe. It will give you details on the conference, but if you're interested in any kind of digital communications, be it ham radio, be it software-defined radios, how to create software for them, how to build them, any of that, this is a fabulous conference to go to by the movers and shakers of digital communications. The TAPR group, of course, has been around since the very beginning of packet radio. So it stands for Tucson Amateur Packet Radio, I believe. So it's going to be a great conference. It's Friday and Saturday of this week. And if you go to that website, you can walk in. You don't need to pre-register, but you can sign up on that website, and highly recommend it. I'm going to be there both Friday afternoon and Saturday during the day. And I'll be giving I'm their banquet speaker Saturday evening, and it will be about digital communications on high altitude balloons.
All right. Has anybody ever put up kind of a little repeater type system, maybe for digital or something, on some of these balloons?
In 1988, just a few years ago, I sent up the first digipeater on a balloon, and we were able to have people relay through it from 12 different states in the Midwest, and they had hundreds of contacts using the highest digipeater until the International Space Station, of course.
Oh, yeah, yeah.
But up until that point, it was the highest digipeater, because it was the beginning of packet radio. And we had a ball using that as a relay satellite, because you can see at 400 miles in all directions at 100,000 feet. So we had great coverage from it, and a lot of people were checking in and talking to each other through the balloon via packet radio.
Well, that's cool. And how long did it stay up?
Well, the typical flight is about an hour and a half to 2 hours to get to 100,000 feet or so, and then the balloon pops and a parachute comes out, so you get another 20 or 30 minutes on the way back down. And so we also have sent up a crossband voice repeater, 2 meters in and 70 centimeters out, and also the opposite direction as well. We've actually had stations out to 700 miles from each other using the balloon as a relay, as a repeater, talk to each other from 700 miles distance. I believe from Kansas City, Missouri, talked to Erie, Pennsylvania through a balloon that was launched in Indiana. So we also did a simplex repeater, which we used a digital voice storage device made by Argent Data. He's got a little box that is a simplex repeater, and we hooked that up to just a single HT. And it's a little different because you have to talk, wait 20 seconds for your voice to come back, and then wait for somebody else to reply. But we had quite a few nice conversations that way over a great coverage distance as well.
Well, I was going to pull one out of the closet. I have a simplex repeater here that about the size of a cigarette package, and they're kind of interesting to work through. you get to hear yourself many times, you know.
And you can do some
Yeah.
sound effects with it too. There's
Yeah.
to indicate when the transmission had been. You can set up different record times. I think the ideal time for a conversation from a balloon was about 20-second conversations.
All right, now I'm going to ask you just another crazy question. Not a stupid question, but a crazy question. If you wanted to put a balloon up like you were talking about there, you know, typically it could go 100,000 feet. Could you actually tether it? And would it be possible to tether a balloon at, say, 70,000 feet? Is that even
Well,
possible?
until some airplane came along and severed the cord. But what would happen is the balloon would tend to, if you try and put up a tethered balloon that's up a few hundred feet, the wind would tend to push it over to one side, so it could be several miles downrange at an angle. So it'd be, and the weight of the string, getting it up 70,000 feet of line, that'd be pretty darn heavy. So
you know, Bill, we at one of the field
military puts
days
up blimps that are 14,000 feet up, and they put TV transmitters and FM transmitters. They had one in Florida where they were transmitting video and TV and radio down to Cuba. And there was a special area that you had to avoid flying, or you're going to hit this massive tether going up to this large blimp. So there was a restricted flying zone there.
So
say probably 14,000 feet would be the limit. Although one fellow flew 3 kites in Canada and got it up about 34,000 feet.
That's pretty good. So you work for NASA, and you probably have heard of this, but we're talking about a string, and it would be too heavy and so forth. But I think in the future there's going to be something available, fiber, carbon fiber or something. In fact, in my information I get, like from the IEEE, I've been reading about the fiber carbon an elevator that's actually tethered on the ground and tethered out at, well, I guess what, geosynchronous orbit. So it always stays the same place out there. That'd be a 22,000 mile piece of rope, man.
That'd be a heck of an elevator ride.
It will. And you're talking about making an elevator.
I think the dynamics of that is going to be extremely difficult to pull off. More likely it would be successful between different altitudes in space itself. There's a lot of factors when you're trying to enter the Earth's atmosphere with something like that.
And they're talking about, of course, making it an elevator. And, you know, I mean, the amount of time it would take to go from Earth up to, you know, space station or something might be 2 days. That'd be a pretty slow elevator ride. Yeah.
Hey, I wanted to talk a little bit about, we talked a lot about the balloons going across the northern hemisphere, but tonight I'd like to show you what's going on in the southern hemisphere.
Yeah, let's do it.
And we've got a balloon flying currently from the AMSAT Argentina group. They have flown quite a few balloon projects, both the standard latex balloons that go up and down, and we've got one that currently is flying, launched on August 31st, about 18 days ago. And it has gone around the world once. It took 13 days to go around the world, and it's on its second lap, and it's running whisper mode, exactly like we're going to be flying for you, using one of my sky trackers and one of those sushi wrap balloons that are made by Scientific Balloon Solutions. It's called their SBS 13. And they are doing great. Unfortunately, the whisper ground stations in the southern hemisphere are scattered quite far, so you're not in ideal skip range. Of course, it'd be even worse if you were flying APRS, because you only have South Africa and Australia and New Zealand and back to Argentina and Chile. That's the only land masses in the southern hemisphere, well, besides Antarctica. And this one is actually creeping down a little close to Antarctica in the last 2 days. It is currently off southeast of South Africa. Have you ever heard of Heard Island? It's
we have, in fact, In fact, we planned for over a year in advance. We had Hurd Island live on our show from Hurd Island 3 Tuesday nights in a row.
Well, we need them right now because the balloon is right over Hurd Island as we speak. And it'd be nice if we had a whisper station listening for it right at the moment.
Well, you know, I think that balloon's been up, what, 18 days? Is that about right?
18 days, yeah.
It's already made it around the world. So, but I guess at not altitude, but lower, what do you call it, latitude? Is it latitude or I get them mixed up, latitude and longitude. Hey, when you get down there close to the pole, though, you can go around pretty fast, can't you?
Yeah, if it gets close enough.
Yeah.
The really cool thing is there's a whisper station in Antarctica, and if I can go to show some screenshots here.
Sure.
Let's see, it's the heart, right? Okay.
Oh, I don't know.
No, here
it's the little boxes, screen. I think.
Start sharing.
Let me get me off here.
Okay, now I got to get off that, and I'll bring up.
You might move the little box, the little Skype box that's on there. You might just move it up to the top corner or something. If
oh.
Yeah, so it won't be, just kind of grab it and move it up to the top so it won't be in your, yeah, just kind of, there you go. Just out of the way.
This is where a really powerful whisper station exists. They have several hundred meters of ice down to the actual ground. They can actually lay their antenna on the ice, and it works great.
Mm-hmm.
They put it a couple feet above the ice so that the snow doesn't build up and get buried. But they could literally put antennas on the ground because the ice is such a good insulator. And they have a great signal. It's an extremely low noise environment. And they have been receiving this balloon when no other station can because their noise level is so amazing. It would be a wonderful place to visit. And they just look at that. The Southern Lights.
I've been trying to find someone down there to be on our show, and I mean, I'm sure they have internet.
This would be some of the people I would contact.
Yeah.
In fact, there's I don't know if he's there right now. I'll have to find. No, he isn't.
Yeah, the last person I talked to was from Europe, I think, and he had already come back.
Yeah. But it's a fascinating place. These are all on QRZ.com under the call sign Delta Papa Zero Golf Victor November. I'll have to find out who is currently the op there, and it'd be great to get them on the show.
Yeah, let's do that.
So they have they're usually on 20 and 30 meters. I think they go through all bands though on Whisper. So if you look at the Whisper map and search on DP0GVN, you can see all the stations that hear them. And I've heard them here during certain times of the day. They really put out a great signal, and they've got a great receive signal. So they're one of the prime stations picking up the balloon that's currently going around the southern hemisphere. And I want to show you a special map that the AMSAT LU group for AMSAT Argentina, they have a special map to track their balloon. And this is different from the two websites that I showed you. This is their own special map. And you can see where all the reports have been coming in on Whisper, all the little dots there, the little balloon symbols. Globo is where the actual balloon is right at the moment. And then to the right, there's a shadowed version, and that's where it's predicted to go. So you see it skirting along between South Africa and Antarctica. And that station I just pointed out to you is down here to the bottom left of the screen. That yellow balloon symbol is where DP0GVN is. So we have quite a bit of Whisper activity in Argentina, and Brazil and Uruguay and Chile. And over in New Zealand, there's quite a bit of activity, and Australia. We're going to be cruising right underneath Australia in the next couple of days, so be looking for that. I wanted to show you this amazing station by ZL1RS, Bob Sutton. He has got an incredible antenna array. Ever hear of a beverage antenna?
Yeah.
Well, he has all kinds of acreage on the North Island. He's far away from any city, and so there's very little RF hash, so his noise level is super low. And he puts out these antennas. He said even a single wire beverage that is just one wavelength long is better than all kinds of other antennas. So, well, V-beams, flags, wire collinears, but sometimes the signal-to-noise ratio that you get with a beverage is really incredible. He was able to receive this balloon almost from Australia all the way over to, there's a diagram of how he makes a beverage. Now, this is a receive antenna only, but it is incredible gain. The one he used, he recommends between 2 wavelengths and 4 wavelengths long, any diameter wire. So it's just incredible. And it's you really have to match the impedance. It's 1 to 9 impedance ratio, and the grounding is significant, and the termination resistor is very important. Approximately 400 ohms and 16 feet of wire that goes to ground at the end. So you can find this diagram under qsl.net/zl1rs.bev.html. So he's got all kinds. He's got one antenna. There's a good close-up of his beverage antenna. This is a old antenna that was used many years ago, and once again it's receive only, but oh, can it receive? He was picking up that weak 25 milliwatt signal from many, many thousands of miles away when no one else could. So, and he's got a number of ferrite chokes on the line. He said that's important right at the feed point where the coax comes into the transformer. There's a view of all his acreage. I think one of his antenna is several thousand feet long, and he uses these fence posts. There only has to be about 3 foot off the ground. So he's got them in several different directions. He's listening right now. See the length of that antenna. Wouldn't it be great to have that much land to play with?
Oh, yeah.
There you go. And there's a pattern of his antenna. And he actually has a pair of them. Phased antenna. This has been a fascinating website. I'm going to build one here. He gives some examples of these are. Now keep in mind this. Have you heard of the HIFER transmitters? They're a license-free transmitter on 13.555 megahertz.
No. And
you have to keep the power typically under 5 milliwatts. Most people are sending Morse code or the slow CW, the QRSS slow CW. These are 5 milliwatt reception on 13 megahertz, just below the 20 meter band of stations in the United States as received in New Zealand on his beverage antenna. That's even incredible distance. That's Connecticut, Illinois, Tennessee. So really phenomenal antenna. He uses these fence posts that you can drive into the ground with your foot and puts insulators on them. Well, actually, they're plastic if you just want to put a temporary one up. And they're pretty easy to put out, and any diameter wire will work, whatever you got laying around that's 2 wavelengths long, or even a wavelength. So just thought I'd mention that because that's a really cool antenna when you're doing whisper and really want to get maximum gain and know what region you want to take a listen for to enhance your antenna without having to put up massive antennas on a tower. So that's pretty much what's going on here in the southern hemisphere. You can see the track where I take the whisper data and I put it to aprs.fi. That was about a week ago when it was over east of New Zealand. And Bob's Z01RS had reception clear out to here, where that part is there.
Now, I looked at this today.
All the way over there.
I looked for this today. He's not on HabHub, I don't think.
It's in a bad area where there's no coverage.
Oh, okay.
It had one report earlier in the morning from the Antarctic station. Can you see my
yes, yeah, I see
little hand there?
Yeah.
This is where the Antarctic station is, DP0GVN, and it was able to receive it with one good report. Now, tomorrow and the next day, it's going to be skirting Australia. So tomorrow, it's probably going to be out of range. So the day after tomorrow, it's probably going to be well received by Australia and New Zealand. So, and then it'll have good coverage for a couple of days as it crosses Bob's location there on the North Island of New Zealand.
So let me ask a question, Bill. Is it common, or can this happen? Say a balloon launched in the southern hemisphere, can it easily get up into north and circle the northern hemisphere and vice versa?
Not very easily, but it has happened. An Australian ham, BK2YT, sent up a party balloon that stayed up 3 or 4 weeks, and it went around the world, I think twice, and during one of his flights, it actually headed northeast out of New Zealand, crossed over into the northern hemisphere, it went all the way up to Cuba, came back down, and went back to the southern hemisphere before it hit Africa.
Wow.
So it's hard to do, and it's a risky area around that area because the thunderstorms tend to be higher and more numerous along the equator. And we just had one balloon from Atlanta, Georgia. He had a great flight off the coast of Mexico, and then he headed down into here, and there was all kinds of hurricanes and bad weather, and I think he got knocked down. That was KM4 UCV-11. So he was last heard off the coast of Acapulco.
So
and that was
how are the winds?
During summer, the jet stream can go, and his actually probably went into the southern hemisphere.
Yeah.
Now, it might still be flying, it just hasn't crossed any land masses yet. So it is possible during the summer months in particular that you can transition from the north to the south.
Well, and if we launch and we're in the northern hemisphere, with Whisper, we probably should get some pretty good tracking, I'm guessing. Also, I know in the past month, the winds have kind of been going west instead of east. I want to go east, you know?
Right. Well, that's what happened to...
I think the club down in Huntsville or somewhere.
KM4 UCV-11, he ended up going to the southwest and went all across Florida, and then went off the Gulf of Mexico, across Mexico, and then headed out to sea towards the equator.
Yeah, he took almost the same path one of ours did. We went out to the ocean, went down to Puerto Rico, and then we went east to Africa, and he went west to Cancun. So, yeah.
Here's the DCC conference. I'll show you some of the talks there. I'm hearing some buzz.
Have you got
Might be my slow internet.
have you got a phone or something? You're moving around, a cell phone or something, or?
No, it's probably just slow internet. I'm out in the boonies here.
Yeah.
So this is kind of what they're going to be talking about. Bob Berninga will be there, of course, the father of APRS. And we're going to have all kinds of different talks on software-defined radios. And just a lot of interesting stuff. So always a fun, we even have an introduction to high-def digital amateur television. That ought to be a very interesting talk. So well worth attending if you can make it there this weekend.
Well, we're not going to be able to, but you can tell us all about it when you get back.
All right, I'm going to switch back.
All right, yeah.
I wanted to show you. What did I do?
Well, let me do this, and that'll help you.
I'll
do that. That'll help you get things back under control there.
Okay.
You got it back under control?
I think so.
Okay, let me see. Yeah, you do.
Yep.
Yeah.
Well, after all these talks about interesting antennas, I wanted to show you one that I've come up with that will tap into the universe.
An antenna? What frequency? Oh, look at this. That's well, I tell you that I somebody probably understands how that works, and it might really work. Yeah, I see.
I'm sending you a call right now. I'm calling CQ.
Yeah.
I get a reply.
Well, I think the conditions must be bad because I'm not getting it there. Oh, by the way, your new look, several people have commented in the chat room about your new look there, man. I mean, you're looking good.
Well, I got a haircut. I was starting to look like Dr. Emmett Brown from Back to the Future, and that's why I have this hat.
Yeah.
But I decided I'd get my lose a few pounds of hair.
Well, all right. Well, hey, Bill, thanks so much for coming on here tonight and giving us an update on these balloons, and the excitement is still building, man. When the weather gets right, we're going
we got one balloon that may show up in an hour or two, or maybe tomorrow, over Japan. It's currently skirting over the edge of North Korea, no doubt. It's been over Siberia, hovering around for a few days, and it was launched by AK-0SK, Alpha Kilo Zero Sierra Kilowatt -11, and he was last heard over Moscow, and he launched that 2 weeks earlier from Kansas City on a Mylar party balloon. So my prediction shows it hanging around Kazakhstan, where the Space Center is in Russia, and then heading over Siberia. I listened to a few software-defined radios in Siberia, but I couldn't hear anything because they're scattered few and far between. If you want to play with that, WebSDR is a really cool website.
Yeah.
WebSDR.org, and you can listen to software-defined radios that are all over the world on HF, UHF, and VHF. I was able to actually dial into one during a balloon flight that went over Siberia, and it went directly over one of these radios, and there are no APRS stations in that region, but this radio picked it up, and from 7 miles away I was able to copy the APRS signal from the balloon and relay it to the server, so I was able to copy it from 7,000 miles away and have it show up on the map.
Well, all right, Bill. I know you got to go there. We're gonna.
Been a pleasure as always, and
again,
I'll try and have some highlights. They have some interesting displays at the DCC conference of what people are working on as far as digital communications, and I will take some photographs and show you in an upcoming episode when I come back.
Okay, that'd be great. Please do that for us. All right, we'll see you later. Thank you so much.
All right. We'll see you, Tom.
All right, guys. Well, he had his antenna hat. I have, who am I? Can anybody tell who I am? I think I'm one of the Avengers or something. I haven't really kept up with the shows. Oh, hey, back to our question for the night. What's the perfect date? What movie did What's the Perfect Date come from? I saw somebody got it right in there. It was Miss Congeniality. I saw my son come on just after that. He would have, he knows that too. In fact, he thinks that's funny. So anyway, let me get back in my regular clothes here. There we go. All right. We'll be right back, guys. Don't go away. Got lots more going on here. Heard it, worked it, logged it. It's time to get the transceiver that's best suited for your lifestyle. Icom offers a variety of high-performance and innovative products. Make the most out of contesting with one of these Icoms today. The IC7610 is the SDR every ham wants. This high-performance SDR has the ability to pick out the faintest of signals even in the presence of stronger adjacent signals. The Icom 7610 is a direct sampling software-defined radio that will change the world's definition of an SDR transceiver. It has 110 dB RMDR, independent dual receivers, and dual digit select, changing the way entry-level HF is designed. The IC7300 is a high-performance, innovative HF transceiver with a compact design that will far exceed your expectations. It has RF direct sampling, 15 discrete bandpass filters, a 4.3-inch color touchscreen, real-time spectrum scope, and an SD memory card slot. The IC7851 allows you to keep your competitive contesting edge with faster processors, higher input gain, higher display resolution, and a cleaner signal. Icom's IC7851 is a pinnacle of HF perfection. It has dual receivers, digital IF filters, memory keyer, digital voice recorder, high-resolution spectrum waterfall, enhanced PC connectivity, and an SD memory card slot. Visit www.icomamerica.com/amateur for more information on Icom radios.
LDG Electronics provides state-of-the-art antenna tuners for every amateur need. From QRP to QRO, fixed stations, portable and remote, an LDG tuner will match your radio to your antenna using our lightning-fast, proprietary tuning algorithms. LDG is a family-owned and operated company dedicated to bringing innovative, quality products to the amateur market. All LDG products carry a full 2-year warranty that is fully transferable. Support is only a phone call or email away. We're always here to help you. Visit us on the web at ldgelectronics.com.
All right, and we're back. And hey, guys, speaking of LDG, they had a product, and I think they discontinued possibly for a while, but they brought it back now, and it's a talking watt meter. And it's just kind of a neat deal. It's a talking watt meter. Particularly, it's geared for people that have impaired sight and vision and so forth. But I've looked at this thing the last month or two, and it's really a kind of a neat thing. And I mean, even if you don't have any sight problems, wouldn't it be neat to have a talking watt meter? I mean, my Icom radio will talk to me, so why not have the watt meter talk to me? But that's kind of cool. And they donated one to Handy Hams for a fundraiser, and Handy Hams raised quite a bit of money with the talking watt meter, and I thought that was great that LDG did that. All right. Hey guys, I want to talk to you a little tonight about a couple things I was working on. Last week we had a segment about helical loaded loop antennas, or a magnetic loop antenna. And I never thought much about them. I couldn't see how they'd work that well, being so small, and it looked kind of like a gimmick to me. But I talked to the guy that was on last week. I talked to him, and he sounded really strong with that little magnetic loop antenna. And so I started thinking about it. I started thinking about, hey, I want to play with one, experiment with one. So I built 2 of them this week out in my shop. Haven't put them on the air yet. I need to make some improvements to them. But I just want to go through with them and show you how easy it is. There's not but about 3 parts in a magnetic loop antenna. And I want to show you some of the process I went through and some of the things I found. So I've got a few pictures here. A couple of them are kind of sideways, but we're just going to have to deal with that. First of all, a magnetic loop antenna, you need a capacitor. And on most of these magnetic loop antennas, they're using the vacuum variable capacitors. And most of them are coming out of Russia. And they'll do like 5 picofarad to 500 picofarad, so really wide range and can handle very high voltages. You can use a regular tuning capacitor like this. They come in various different values. This one's got some decent spacing to it. So this is the one I thought I would try first and see how it would turn out. Now the thing about it is, on a loop antenna, you get very, very, very high voltages. If you run 100 watts on that loop antenna, you'll have in excess of 4,000 volts on that magnetic antenna. And today I was playing with one in here, and I was running about 5 watts into it, and I got my hand too close to the capacitor right there, and I drew a little spark myself, even at 5 watts. So I'm not sure what the voltage was, but my finger thinks it was pretty high. So again, I just took me a piece of PVC pipe. I put the capacitor on the end right there, and I thought, okay, let's make it simple. I'm seeing loops out there now that are not aluminum or not copper, but they're a piece of coax. So in this particular build, I wanted to go with a 6-foot diameter, 6-foot diameter loop. So the overall length of that 6-foot diameter is what 6 times pi, I think, is the diameter. The overall length of that is about 19 feet long. And what I did is I just cut the center conductor back on both ends there, and I twisted the shield together, because all I wanted to do was use the loop, the outside shield there. So that's what I was going to use to build my first loop with. I used PVC pipe for spreaders. Just put a little cap on there, drilled a hole through it. You can see the 6-foot loop right there. Here it is laying in the garage floor, the capacitor at the top. And there's the little coupling loop at the bottom. The coupling loop at the bottom is just a piece of coax that's hooked to the center pin, and it comes around and it hooks to the ground side of the SO239. So DC wise, it's a direct short, but at RF frequencies, of course, it has an impedance there. So the way you calculate these is the little loop there, the little loop that you excite, is approximately 1/5 the size of the big loop. So that has I think I said 6-foot diameter a while ago. That's a 5-foot diameter, actually. Maybe it's a 6-foot diameter that I was shooting for right there. I couldn't remember now. That was a 6-foot diameter. So that loop turned out, total length of that little loop there was probably 31 or 32 inches. But you can see it's only about a foot across. So I placed it at the bottom, and just used some tie wraps, just connected it there. And let's see. There's a capacitor on the other end. The outside loop hooks to one side of the capacitor, and the other side hooks to the other side of the capacitor. And there it is, basically all put together. Now, one of the things that I've noticed about this was the tuning is very, very critical on it. And even the flexible loop here, that loop won't really maintain a circular form. Just gravity makes it droop and different things, you know. But with that capacitor and the loop, and the little loop down here that I was driving, I got some pretty good results actually. And you just have to look at this sideways here. On 40 meters, you know, I saw about a 1.2 match on 40 meters by turning the little capacitor by hand. Here it is. Let's see. There it is again. Close-up picture. About 1.3 or 4. Here it is again. Okay, here it is at 10. I went up to 10 megahertz. Look at that right there. It's about a 1.1 at 50 ohms. And I tried it on all bands, and it would actually tune from 80 down to, it wouldn't quite make 20 meters. It would go down to about 13 megahertz. But it was an interesting experiment. So I did take that capacitor off, and I put a smaller capacitor on, so as I could go down a little or go up higher in frequency. And when I did this, I think I lost 80 meters. But let's just see what pictures here are. You're gonna have to look at it sideways again. The little loop that you drive with RF. I put mine on top. You can put it on the top or the bottom. I think you can put it on any of the sides, actually. I think it needs to be opposite of the tuning capacitor. Tuning capacitor on the right side there, loop on the left for the input. So after changing, here's a little video. Let's see if we can hear it here. I'm doing a sweep right there. Watch the SWR on a sweep. You can see how sharp it is. Very sharp. Look at the graph here over on the right. On 20 meters, it's got about, maybe 20 kilohertz of bandwidth.
About 280. It's almost a one-to-one match. Let's do just a frequency sweep and see how it looks like it's tuning.
I think it's repeating. Okay, we're gonna watch it one more time. So we're sweeping. So it looked like at about 14,280, it was just a perfect match. Very narrow banded. All right, very narrow banded. Now that was the coax loop.
Like
so I said, okay, well, this is interesting. This is, you know,
frequency sweep and see how it looks like it's tuning.
It might work, you know. I'm starting to see that if I can build it and it does that, then it might have, you know, it might work with a little fiddling with it. So I went out and I got me some copper. So I built me a square loop out of copper. One of the things I found on the round loop was it's not very rigid, and it was changing shape on me. And of course, when it does that, it changes resonant frequency. It does all kinds of things. Also, I headed to my shop out there, and if you guys remember my shop, I've got a hoist at the top of the ceiling, and I'd pull this antenna up with that hoist right above I have an 8-foot table there, and I would try to adjust it there. Now the 8-foot table had it's got an 8-foot piece of steel that goes around in it. My hoist up there's got a lot of steel up there. So I've got a lot of metal around this. But so I said, let's try to stabilize this a little bit where it doesn't flop around. Maybe it'll be a little bit more stable. So I took me some copper pipe. Those are 5 foot each length, two 10-foot pieces. So I thought, okay, let's mount a SO239 in the bottom so we can at some point hook a coupling loop in it. So I just flattened it out there, and we drilled a hole, and that's where we're going to feed it with, right like that. Again, I used a piece of PVC pipe, And on one end, I put a little a piece of wood there to screw the capacitor on. This is the only point that the loop is broken. In other words, it's not a continuous loop. The copper pipe is not continuous. You break it right there where the cap goes. So this is where I'm going to try some different caps in there. So that was my mount for my cap. So you can see I kind of laid it in here to try to figure out, how things are going to fit. Let's see, there it is again. And there's the cap that's connected in there right now. So that's the first cap I tried. Now this cap has fairly good spacing. You would think it would handle several hundred watts, but it won't handle. I mean, we're talking. If you ran 100 watts, this cap typically would not handle that. You would need probably quarter-inch spacing at least. That's why the variable vacuum capacitors are used here. Now, a variable vacuum capacitor, they're all coming out of Russia now. You can see them on eBay. They run anywhere from $125 to $140 for a variable air capacitor. I didn't want to do that for theory and for practical testing. My rotor stator capacitor here will in effect do the same thing. It just won't handle the power. So there it is there. That's just the one end where I was going to put the input into. Now I did try the loop. You know how on the round 6-foot loop I had a little, like a 1-foot loop that drove it. You should be able to take that same 1-foot loop and position it here and excite this 5-foot square loop. It didn't do very well. It didn't do well at all. But I finally went to a gamma match here. I built a gamma match. There are no specifications that I can find that show length and distance between the antenna element and the gamma match and so forth. You're going to hear me refer to this as a delta match in here. That's an error that I made. A delta match is two gamma matches. It's one on each side. It's like a T. So this is really a gamma match that I'm trying to do here. So let's see. I think this may be. Let's see what this is. So if we look at this, look at there. With that capacitor, I went to 3938. Look at the match. 3938. It was solid. About a 1.1 at 50 ohms. I mean, I was really surprised. That was really cool. Really cool there. So there's a picture of it, kind of pulled up with my lift there in the shop. If you notice that metal table below it, that's got a metal ring around the bottom of that table, so I'm sure it has some effect. And then at the top, I've got a big motor and metal up here. Let's see what else we got here. There's a picture of the capacitor again, and you can see the knob on there. Now, the thing about this is, even though it's a plastic knob, when you touch that knob, there is some capacitance from your body that will affect it. So I had to kind of tune past the dip point, and then when I take my hand off, it would go back down to the resonant point. What we would normally do here is to put a motor on there and drive it with, say, 12 volts. And that way we could turn that capacitor without having to put our hand around it. So I've got several gear motors here that I might pull off something. I even ordered one off of eBay to go on there. I ordered a 2 revolution per minute. And you think that's kind of slow. Well, the more I'm reading, people that have built this have used a 1/6, or I mean a 6/10, a 0.6 revolutions per minute, because this tuning is so critical. If you just turn that normal speed, you'd go across the dip so fast you wouldn't even see it. So I found that you had to tune very slow. And when you did see that SWR coming down, you had to be very precise in tuning it there. Now here's a gamma match I made. The loop didn't work, so I said, okay, I'm going to try a gamma match. So I just took me a piece of wire as a gamma match, and you can see it's hooked to the coax connector there, the SO239. It's bent, and it goes straight across to a little metal tab I've got there, and I can slide up and down that pipe. So, man, once I put that on there, it started really looking really good. I could get like a 1-to-1 match, and it was looking really good. So I later took that wire out. Well, there's a close-up again of the wire for the gamma match. There it is on the distant end. I found a little thing here at Lowe's that is a pipe hanger, and it actually snapped on that pipe, and it allowed me to slide that back and forth along the pipe there. So I took that off. Once I saw the gamma match work so well, I took that off, and I bent me some 3/16 copper tubing and made me a gamma match out of some 3/16 tubing here. Again, I can't find any good formulas or measurements on how wide to space that or how long. It's totally trial and error. If you've got a round loop, if you got a round loop, your gamma match will actually curve round inside the loop here. So there it is again. You can see that little strap I've got there. I've got a hole through it, and I can actually slide that slider in or out, changing the length of the gamma match there. Here we are on 40 meters. Look at that, 40 meters, 7105. Looks like about a 1-to-1, 50 ohms. I mean, it was really exciting, but again, very narrow, very narrow. I changed the capacitor to see if it would give me a different tuning range. That first capacitor gave me 80 meters, but I couldn't quite make 20 meters. It wouldn't quite go that high. So I changed to a lower value cap, and now I'm getting down into the 20 meter range, but I've lost the 80 meter range. Now, there may be some interesting things we can do there, like switching in an extra capacitor or something. There's some great possibilities there to make this thing all bend. Here's another video. Let's see what it says. I made me a very cheap gamma match. Made a very cheap gamma match. I'm going to show you what kind of matching I'm getting here. Let's see if I can. I'm standing. I mean, you can see I'm standing. Let's see if I can do this. This close to the antenna. Doesn't seem to be affecting it very much. You can watch the as I tune the capacitor here. I don't know if we can see the meter over there or not. It's really it's just about maxed out here with capacitance, but it gets the match down pretty low. Again, I'm standing right beside this loop, and I'm moving back and forth, and it does not seem to be affecting the loop any. There it is, a little better, a little closer. So you can see I've got a fairly good match on 80 meters at 3933. Let's see how wide it is. The loop's going to be very narrow. So my 2-to-1 is going to be about, if I can get it here, I don't know, 39. Let's see, probably 3940 to about
3927. I got about maybe 13 kilohertz bandwidth there. Let's go to 40. Let's go to 40 meters and see what kind of match we got on 40. We'll just try to go right there. Again, I'm going to tune the capacitor here. You can watch the meter over there for a dip. Okay, so here we go. Okay, I didn't see a dip. Let me go back. It's hard to do this with one hand and trying to film. Looking for a very quick dip. There's one right there. It's very sharp. You can see how sharp it is. Boy, it's, you just barely touch this capacitor. I probably have to change out my capacitor. Okay, so that's on 40. Let's see what the, that's on 40 meters, so. And again, my head is inside the loop right now. I'll show you how, my head is inside the loop, so you'd think it might affect the, you might think it would affect the pattern, but it's not. So 7224, let's see our bandwidth here. So we're going to go up to just a 2-to-1 bandwidth. There's 72, about 7240. Let's go the other way. 71200. So it's about 40 kilohertz bandwidth there. Let's just see real quick if we can go down to, let's take the next one down. Let's go down to 10 megahertz. Let's just see if we can hit a spot there. So here we go. Going to try to tune it here. Okay. So very critical tuning. Very critical tuning. You can see. Well, I'm gonna leave it right there. So, and I've got my head inside the loop right now, but you can see we got a fairly good SWR there on 10, and we've got still a little. We can still get a little bit less capacitance. Let's go to 20. I don't know if it's going to do 20 or not. Let's try 20 meters. We'll try right there. Oh, not going to quite make 20. That capacitor, the capacitor is at minimum right now. So we're not going to make 20 meters. Let me just back it up to about 13.5 or so. 13.6 good. So I think we should be able to tune that. So yeah, the antenna's rotating. I can't hardly tune it with one hand, but all right, so and we're at minimum capacitance here. If you look at this, this is all the way out. So with that capacitor on, go down that low. Let's go down to let's go down to like, well, we tried 10 a minute ago. We can hit 10. Let's just go to 9 megahertz. I think we can probably get 9. Very critical on tuning the capacitor. Very, very, very critical. But you can see we're about 50 ohms and a very good match there. So what we're going to need to do, we're going to need to change out this capacitor. It's going to be doubtful I'm going to be able to go, 80, 40, 20. That's a pretty wide range. So probably set it up where I can do 40 meters and up, maybe 40, 20, 15, and so forth. Let me show you what I did for my the loop. the loop coupling did not work. Let me show you what I did. I made a very basic delta match. We're going to bring it down. All right, so here's what I did for the delta match, guys. You remember remember we put the connector here, and we should really run maybe a 1/4 inch pipe. Let's take it the other way.
All right, we'll get off of that. Here's another, just a real short video here of tuning. So you can see we got a pretty good match on 80, on 40.
91. So we got about 40 or so kilohertz bandwidth.
And again, there it is. I brought it in the shack to try to hook it to the radio to see if I could hear anything on it. The bands were so bad that I was barely hearing anything with a regular antenna on it. I did hear a few signals. The thing about this is it's very, very critical for tuning. It's got a very deep, sharp resonant point. So I could listen to the receiver, and I could turn the capacitor where I could hear the most noise. I would stop. Of course, I'd be way off. I did put the transmitter in transmit and keyed it up, and I saw the SWR, and I was able to just, let's say, key down on AM. I was able to actually turn the tuning knob to get the SWR down to 1-to-1. So it will be, you will be able to, without any special gear, I think, to get this tuned with a radio, just with an SWR meter. Thing is, if you go from 7150 to 7180, you're going to have to retune it for sure, because it's only got about a 40 kilohertz bandwidth to it there. So that's kind of my experience that I had this week just building these. I didn't take it outside. I might have had better luck if I'd taken that loop outside the window here and just put it up on a ladder or something and ran the coax in and tried it. But I didn't do that. But it was interesting that I was able to get those results. And I'm thinking now, okay, I'm going to try a little bit smaller loop, because people are building 3-foot round loops now that are doing 20 through 80 meters. And I'm going to try it again. I may have gone, so big that it's causing me some issues, particularly in my shop with all the metal and stuff around it. I'm sure it's detuning it. I think if I get something a little smaller, I can get it away from, like in the shack here, get it away from a lot of metal and so forth there. Let's see. I was going to open the phone lines just for a few minutes here, if I can figure out how to do it. Not sure I've got it on. Yeah, the phone lines are open right now. So let me put a phone number up here if anybody wants to call in. The phone number is going to be there's the phone number right there, 712-775-7270, and you'll have to put that code number and a pound sign in. But if you want to call in, and it's about 10 after 9, so we'll just open it up. Open mic night now, if you guys got anything you want to talk about or any questions. So that's the first experience I've ever had with a loop. I was kind of impressed with it, that it actually would come to resonance. I'm sure the body and the hand next to it does affect it. So once I get my gear motor on there, I'll be able to tune it remotely at a very slow and very precise rate, and we'll see if that improves things. I think I need to work on improving the gamma match too. If you want to call in, 712-775-7270. Tom, I had echo. I don't know. I don't have echo now, I don't think. Oh, you know what? I would have had echo. Now I don't have echo. Oh, one of the controls on a mixer that's there for a certain purpose is necessary, but when you don't want it, it does cause echo. So hopefully you guys heard me and I just had a little reverb maybe, maybe it sounded okay. Or we can repeat the show, but not tonight. All right, if you're hearing music, that means the phone line's open. And it means that it's going to play music until somebody calls in. So I'm thinking about maybe a round loop again, and a smaller one. I really don't have anything here to bend the copper tubing with. I guess you could hand bend it, probably in a diameter 3 foot. It's probably possible. But I happen to have 100 feet of brand new 7/8 inch cable TV hardline out there. Of course, it's aluminum. But last time the cable company's here, I said, you got any spare pieces of cable out there that you've taken down somewhere? And the guy said, sure, I'll get you some. So I walk out to this truck and they've got a 6-foot reel on the back of the truck, and he says, how much you need? 100 foot good enough? I said, yeah, 100 foot's good. So they grab it and they start walking down the road with it, and then they cut it off. So I'm thinking about using it. It's pretty stiff, and it would be easy, I think, to get into a circle. On the ends, I won't be able to solder to them, but I probably, just for testing, I'd probably use something like some stainless steel hose clamps to clamp onto that. I think we got somebody on the phone. Who's on the phone?
Bill Horn, W4EWH.
W4EWH. Hello, how you doing today?
Well, thank you. I'm hoping you can solve a mystery for me. And it's kind of a theoretical question. I was told magnetic antennas didn't have an electrostatic field, that their whole reason for being was to cut down on noise reception, because most man-made noise is electrostatic. Is that an old wives' tale, or is there some truth to that?
Well, I don't know. I'm learning, but let me tell you, it does have some unique differences. This is a magnetic field instead of and I forget what the other field is for radio frequencies now. But when you take a regular loop, the signal goes broadside to the loop, off the sides of the loop. But the thing about a magnetic loop is the signals go in the plane of the loop. So, it will be directional, and you will have to turn that loop for certain directions. But it generates a magnetic field instead of a magnetic field is an electrical field. Maybe we've got some experts on here that can maybe help clarify that. Been a ham for 55 years and in engineering, electrical engineering all my life, but this is kind of new to me. At the other end, you still pick it up. It's just like a radio signal, but it's a magnetic generated field. Again, it's off the edges, not broadside. So,
Well, does a magnetic loop have an electrostatic field? That's the question. If you do a side-by-side comparison between a magnetic loop and a regular one, does the magnetic loop suffer and receive capability by comparison?
Well, I don't know. I haven't gone into it deep enough yet. I haven't really put it on the air yet. I tried to today, but the bands were so bad. The signals were really bad. So I think the magnetic loop is much better to reject noise and noise that's generated in the areas. But again, all this is to be determined for me. But if you're interested, there's a lot of articles out there on magnetic loops. You just key in magnetic loop and start reading, and there's a lot that different people have built. All of them have somewhat of a variation to them. But I think the most important thing that I would like to do that I'm not going to do just because of the cost, and I don't want to trash this thing or throw it in the garage when I get through with it, but it's the air variable capacitor. That'll allow you to run much more power, and it'll handle voltages in the 4 to 5,000 volt range. And again, hooking the motor on there, the drive motor on there, the gear motor to tune it is almost necessary, because you probably saw the antenna analyzer when I was tuning it. That dip would be so fast when you go across it, and I was just barely moving that capacitor. So that's why they're driving them now with motors that have a ratio of, they give you something like 0.6 of an RPM. I mean, it's so slow. It's like watching, paint dry on the wall.
Oh, just finished having my house painted today. I know how that feels.
Yeah.
Okay, I'll let others answer. It's just something I've often wondered about. But let's see what we can turn up.
Well, I'm interested in it. I don't think, and again, I think a magnetic loop is going to be a compromise to any big antenna you put up. I just don't think it's going to perform as well. It's got a certain amount of dB loss, more than a dipole or a vertical or something out there, a full size antenna. The thing about it is that you would be able to put it inside your house if you're in a HOA, put it in an attic, or put it in your ham shack or somewhere like that, which it's better to have an antenna in the ham shack than to not have one at all. And that's one of the things my son's facing right now in an HOA down there, is they're very strict on anything outside. So this could be a solution for him. And like I've told people in the past, if you didn't have the two to compare by, you'd never know the difference. In other words, if I had a mag loop here and I'm talking to you in, I don't know, North Carolina or wherever, I'm talking to you in North Carolina. And if I didn't have a dipole out there to switch to and make a comparison, I'd probably never know the difference. Because, one day I could be on that dipole and I wouldn't even hear you in North Carolina, or you'd be so weak and you can be so strong on a loop. So it's better to have something that works, even if it's a lot less gain or negative gain than to have nothing at all.
So you're saying then the magnetic loop is better as a receive antenna than as a transmitting antenna?
Well, I don't know. I personally have not been able to make that comparison yet. I know it probably, both receive and transmit, would not work as well as, for instance, if I had this loop running on 40 meters and I had a 40 meter dipole out there, 50 feet in the air, and I had an antenna switch, I just about could bet you that the 40 meter dipole would probably be, a couple S units stronger. But then again, if you can't put that dipole out there and you can just have a magnetic loop inside the house and it works, and you can talk to places that you can talk to on a dipole, I mean, that's still great. I mean, even when I'm on my 40 meter antenna, one day I might talk to Dallas, Texas and get an S9, and then another day I may talk to Dallas and get a S4. It just varies. So the loop, I think it's got some good possibilities. And I'm thinking about my next project is going to be probably a 3-foot round, and motorize it. I'm still not going to put the vacuum variable on there at this time.
Is the loop mostly intended for a limited space or homeowner or condo owner environment?
Yeah, I think that's the reason most people are getting these loops is because they cannot put an antenna outside. They can't even put a mobile antenna out on a patio. They get written up, or they can't put a piece of wire out, so they have to do something. So they're actually putting, and there's pictures on the internet where people are actually putting these loops up in their attic. And of course, since they're motor driven, it's real easy down in the ham shack to change bands, and it's functional up there. Now, the ones I saw in the attic were fixed, but you see people have these magnetic loops out in their backyard. Some of them have antenna rotors on them because it is directional. As I mentioned a minute ago, it's directional off in the plane, off the sides of the loop, not broadside, but off the ends of the loop. That's where the signal goes, and it's just like any antenna. It is going to be directional, and they're putting an antenna rotor on it, and they're actually turning it. And my understanding is, from what reading I've done this week, is a 6-foot loop, if it's 5 feet off the ground, it'll work just as well there. I mean, the ground does not seem to affect it very much, so you can set it down low and it will work pretty good. Now, there's commercial loops out there you can buy. Of course, MFJ's got them. DX Engineering, many people make them. Very expensive, and I'm assuming that's because they got the vacuum variables in them. I don't know that for sure. Especially if they're rated for high power. If they're rated for 100 watts or more, they're going to just have to have a vacuum variable in them. If you want to run QRP,
another question.
Yeah.
Yeah, somebody in the chat group mentioned a trombone capacitor. What is that?
Now, what kind of capacitor?
A trombone capacitor.
Oh, a trombone. Well, a trombone basically, and I'll give you a real crude example of a trombone. A trombone is when one part actually slides in and out of the other. It could be a piece of copper pipe, and you could actually take the center conductor of, say, some RG8 and slide that in that pipe. And as you slid that center conductor in and out of that pipe, that actually will vary the capacitance. It'll vary the capacitance. So, and hey, a very crude example of this, you can make, and a lot of people make their own butterfly capacitors. They cut the plates out and put all this together with screws and bolts. But one I saw used a couple that looked like Coca-Cola cans. Well, it was two Coke cans, and they must have been some other brand can, because they had the end cut off with two of the cans, and those two cans were mounted on like a board, and then below it, two more cans were mounted on a board, and they would go up and down inside the top cans. So by varying those cans in and out of each other, of course, that's changing the capacitance. So that would be a trombone type capacitor.
Okay. Are those less likely to arc over than regular butterfly caps?
What was your question?
Are the trombone caps less likely to arc over?
Well, it just depends on the dielectric or the gap that you've got between them there. I mean, you can take a regular rotor, a stator and rotor type capacitor, and if you've got wide spacing, for instance, if you've got 1/4 inch spacing, it'll handle a whole lot more current than one that's only 1/16 of an inch spacing. Here's a capacitor I'll probably play with here. I don't know if you can see it or not. This is one. MFJ actually built this, and I don't know if let me see if I can get it close to you. This is like it's two capacitors with a rotating center, and this can be hooked up in a couple different ways, but you can see the spacing on here is quite large. So the spacing is quite large on here. this ought to handle several thousand volts pretty easy. So one of the things I was going to mention about using a variable capacitor is how you connect it. In other words, if you have an air variable capacitor, let's see, I don't have it in here, but if you have an air variable capacitor, this shaft is actually on a little bearing. It's on a little bearing point. And that's the only thing that makes connection, is that little bearing point. And with a magnetic loop antenna, you're looking at impedances of milliohms. You know, you're looking at impedances not 50 ohm, but you're looking at impedances of 0.001 ohm. You know, and just the little bearing, or the little ball right there in the end that takes this rotor, will generate so much extra resistance that it greatly affects the efficiency of the loop antenna. So you can imagine, I mean, hey, at DC, that little ball bearing there at DC, it probably would check out as short, you know, with an ohm meter. But as you get up into these higher RF frequencies and high power, that little point right there actually generates you some problems. Now, there's a way to get around that, and that is if you got like a dual capacitor. You've seen a lot of the capacitors that come out of old radios. They had two sets of rotors. If you remember, if you ever look at those, when you turn a little knob, you got two different sets that kind of come up like this. So what you can do, you can use those two sets. This set connected to one side of the your loop, and then this set connected to the other side, and then the rotor that turns, you're not even using that rotor. You're not using that ball pivot point. You're just moving those vanes inside and outside of those two split capacitors. So there's no milliohm increase or resistance or anything there, because you're not using the rotor. You're basically using it just to change the capacitance between capacitor, you know, section 1 and capacitor section 2, and you're just, you know, tuning that down in there. So that's the way they're getting away with using a lot of the air capacitors, is by not hooking the rotor up, but using a split capacitor to do that with. This actually is two capacitors in one right here, and I can do the same thing with it here. One side would go to one side of the loop, the other side goes to the other side of the loop, and then the rotor here just would spin between them, and it's not physically connected to anything. So that's
no current in the roller in the stator conducting in the stator contacts.
Yeah, what was your question?
So therefore, you get no current in the
right.
Right. Contacts that contact the stator.
Right. There would be no current at all. Yeah, and this is high current, man. This is like, there may be 15 amps at 4,000 volts. So there's no current going through that little bearing there that allows you to swivel that rotor, because you're using the split thing, and you're just tuning these vanes in between them. So that little bearing does not come into play at all. That's how they are eliminating that loss. Now the two rotors you saw in my video are just single rotatable capacitors, and I was using the bearing, of course, again, low power. Hey, I think I had 5 watts on the thing, and I got my hand too close to that capacitor, and it actually zapped me. So, I mean, it generates quite a bit of voltage even there at low power levels.
Yeah, it's well, they are fascinating devices, but you know the overall impression I'm getting is that they're for real engineering environments and not yet ready for prime time. Is that your? Would you agree to that?
Yeah, and I saw in the chat room, Richie said MFJ makes their own capacitors. This is an MFJ capacitor, and if you look at this very closely, this is all handmade. You can see little spacers. That's a long screw. It's a long screw that goes all the way down through there. You got spacers in here, and you got these little vanes that they punch out in metal, and they put them all together. They put an end on there and an end on there, and they do the same thing with the rotor in the center. Now, a person can actually make a capacitor like this, and you'll see if you look at loop antennas on the internet, you'll see some people actually show you plans on how to make a butterfly capacitor. The thing about the MFJ loop is their capacitor, and I don't think they use the air capacitor, but they use one with great spacing, and it's probably rated at low power. But every joint, if you notice here, these joints are just a spacer and a blade and a spacer and a blade and a spacer and so forth with a bolt through there. For their loop, MFJ welds, they heliarc, or whatever, they weld all this stuff together. And even their loop, even the aluminum loop, the 3-foot, 4-foot loop, everything is welded. It's welded to the capacitor because you're dealing with milliohms, and that's why everything is welded there. So I knew trying to build one out of a coax loop and bolts and bolts and lugs and nuts and stuff, I knew I'd probably have some loss. I built these two just kind of as a proof of concept to see what kind of action I could get out of them, and I actually saw some pretty interesting results.
Well, it does sound like a very big project, and my compliments to you for seeing it through. I hope it does work out. I'm sorry, I'm getting a battery warning on my phone here. So,
that's all right.
673. I don't want to hog your time in any case, but thanks for helping me to understand it.
Well, that's all right. Well, thanks for calling in. And it's 9:30. It's probably about time to close the show down anyway. But we want to thank everybody for tuning in tonight. And if you just tuned in, you can always watch the show on w5kub.com. If you're listening on international shortwave, send us an email to Tom at w5kub.com. And we'll see you next week. Hopefully Katie be back. She's been out a little bit, but she hadn't quit us or anything. Katie should be back next week. I think Dave has just been real busy, but Dave should be back too. So we're looking forward to getting the gang back together again. Thanks to everybody for tuning in tonight, and I learned a lot. I'm no expert on loop antennas. This is just something I found this weekend and I played with. So I would suggest to you just go out and experiment with it. You noticed on that loop it wasn't but like 3 parts. You got an outside loop. You got a little inner loop that you drive with your radio. And you got a capacitor. That's all it is. That's all it is to a loop. And then you just got to kind of figure out how to hold it all together. I use a piece of PVC pipe with a little board attached to the top, so play with it. And I think you'll have fun there. 73 to everybody. Thanks a lot for joining the show tonight. I was going to look and see any new people that are tuned in that haven't been with us before. I was looking through the list here. All right. We had a good net. Well, I don't say good net. We had about 10 people check in tonight. The band wasn't really good tonight, but we've had some great nets before. Join us on 40 meter net, 7180, about 5:30 p.m. every Tuesday. So stay me through, everybody. We will see you guys later.
So you're saying I can ask this cat any question?
The cat is connected to the computer. You just type in the question, it will read his mind. There the answer comes.
You're the man! I've been looking for this for weeks.